Okay, so this is the assignment that is coming up for this week. Some of you have already done it. Anyway, I knew since there was a lot of math involved, I wanted to walk you through it, usually like we do in class. So molarity, we're talking about moles still, but now we're talking about usually moles in a solution of water. So our units that we want to have every time are going to be moles and liters. On some of these problems, I was nice and went ahead and gave you both of those, and really it's just a simple division problem. A couple of them, I gave you grams, and you have to convert to moles, which I know it's been weeks, so that's mainly why I wanted to come on here and remind you how to do that. And then some of them give you milliliters, but in order to use the equation from molarity, you have to have moles in liters, okay? So this problem says I have a solution that contains 0.35 liters of water, so that's good, we do have liters. But it says we have 36.46 grams of HCl, which is hydrochloric acid. So we don't have moles. So what we are going to have to do is take this number, 36.46 grams of HCl, okay, and we have to figure out how many moles that is. So I don't know if you just Googled a periodic table or if you happen to have your binder with you at home, but I just looked all this up online. I don't have a paper copy at home with me. So remember, to convert to moles, we need to have a second fraction, okay? We want grams to cancel because that's not what we're looking for, that's what we have. So I'm gonna go ahead and put grams on the bottom. You know, I like to write my units first. And whatever you are solving for, what you want, needs to go on top of the equation. Okay, so 1 mole of HCl, so the number that's going to go right here, I have to look up the molar mass of hydrogen and add that to the molar mass of chlorine, and that just comes straight from the periodic table. So that number, when you add the molar mass of hydrogen, which is really close to 1, remember it's really small, when you add that together with chlorine, neither of them have to be multiplied because we only have 1 of each, okay? So when you add those together, you get about 36.46 grams. So we actually have exactly 1 mole, okay? We have 36.46 grams of hydrochloric acid, and that's how much 1 mole weighs. So whenever you divide this and multiply across, you're going to end up with 1 mole. Okay, that's how many moles we have. Anybody have questions about that part? That just happened to equal exactly 1 mole. That's pretty convenient. Okay, so now the problem already gave us liters. Okay, so we didn't have to do any conversions with that. So now we have liters and we have moles. And this over here, a capital M, that is the equation for molarity. How many moles you have per 1 liter of solution, okay? So this problem just wants us to find the molarity. So all I do is I'm gonna write 1 mole of HCl, and we have 0.350 liter, okay? So when you divide, you get 2.86 mole for every 1 liter. That's what that fraction means, okay? It means that, it kind of means like per, or saying for every 1 liter, okay? So we have we have close to 3 moles of hydrochloric acid for every 1 liter of solution that we have, okay? So, sorry, I know I'm kicking the table. 2.86 moles per liter is our final answer for that one. Instead of writing moles per liter every time, you could also just write a capital M, okay? Does anybody have questions about that one? We had to convert from grams to moles because to figure out molarity, you have to have moles, okay? And this 36.46 came from the periodic table. And I promise, well, let me think about it. Yeah, I promise after this week, we really are done with the mole. I know I keep saying that, but we really are done with the mole after this week, okay? So problem number 2, again, it says determine the molarity. So molarity, a capital M, is moles per liter. So we have a 0.654 liter solution. So good, we have liters. And we have 0.444 moles. We actually have no conversions to do this time. Okay, this is the easiest possible problem. We literally just have to set it up. So 0.444 moles, and we have 0.654 liters. No conversions needed. Okay. When you divide, you get 0.679 moles for every 1 liter. Another way to write that is just putting a capital M. So that one was pretty simple. We didn't have to convert anything. So our final answer for the second one is 0.679. Questions about that one? That one has
No,
sorry, somebody say something? Everybody good? Okay. So this is the last one on this page. So this one says determine the molarity. So again, we need moles and liters. Okay. So determine the molarity of a 400 milliliter solution. So we're going to have to do some sort of conversion there because we have liters, not milliliters. Okay. And we have 98 grams of phosphoric acid, which is H3PO4. So we actually don't have either unit that we need. Okay. So I'm going to show you how to convert for both. So let's start with the milliliter issue. Okay, I'm going to do this down here in a different color pen. You can see it's too close in color. Okay, let me get green. Okay, so we have 400 milliliters. Okay, but I need that to be in liters. I'm going to draw my fractions. Remember, whatever unit you want to cancel needs to go on the bottom. So I'm going to put milliliters down here. And I want liters. I'm going to put that on top. Okay. So the prefix milli, M-I-L-L-I, means 1,000. So 1 liter contains 1,000 milliliters. So we don't have a whole liter. We would need at least 1,000 milliliters. We only have 400. Okay. Milliliters cancel. I'm left with liters. When you take 400 and you divide it by 1,000, you get 0.4 liters, which makes sense because I just said we don't have a whole liter. Okay, we have kind of close to half of a liter. All right, so now this problem is taken care of. Okay, now we have liters. All right, so that's done. But we have one more conversion we have to do. That is because we need moles, but we were given grams. Okay, so I'm going to start by writing what they gave me. 98 grams of 3PO4. Okay. I need to figure out how many moles that is. So again, I want grams to cancel. Okay, so I'm going to put moles on top. So again, I'm going to put 1 mole here. We need to figure out what 1 mole of phosphoric acid weighs. Okay, so this number that's going to go right here, I need to look up the molar mass of hydrogen, multiply it by 3. I need to look up the molar mass of phosphorus, but I'm not going to multiply it by anything because it's just 1. Remember, when there's no subscript, we just assume that there's 1 atom. And then I'm going to take the molar mass of oxygen, multiply it by 4, and then add that. So when you add all of that together, which I've already done, I'm not going to make you do it, it's close to 100. It's actually 97.99 grams. So again, I did not write these problems, but whoever did was doing this on purpose because again, we have pretty much exactly 1 mole. Okay, we have 98 grams and 1 mole weighs 97.99 grams. Okay, so grams cancels. Okay, we have moles. When you take 98 and you divide it by 97.99, you pretty much get 1 even. Neither of those are our answer. Okay, so, but we now have moles and we have liters. Okay, now we can use this equation over here. All right, I'm kind of running out of space, so I'm going to move it over here to the side. So to get our final answer, neither of these are the answer. Okay, I'm going to put moles on top. 1 mole, 0.4 liters. Okay, when you divide, you get 2.5 moles for every 1 liter. So for every 1 liter of water that we have 2.5 moles of phosphoric acid. That's what molarity tells you. How many moles you have for every 1 liter of any kind of solution. Okay. Does anybody have questions about 1, 2, or 3 on this page? Number 1 was 2.86. Number 2 was 0.679. Number 3 is 2.5. Okay, I'm going to leave this on my screen for just a second for anybody who's joining now to look at this. So just give a couple minutes, and then we're about to do lesson number 2, where there are 8 problems, and I did the first 2 for you, where it's still talking about molarity, but it's using it as a conversion factor. I'm going to leave this up for just a second, and I am going to post the key on Google Classroom later in the week. We're not counting off for any late work or anything. So if you would rather, there's not going to be a penalty for late work. So don't stress about if you're unsure of something. We really just need for you to kind of attempt it and turn it in, and you're fine. So like I said, the first one involved 1 conversion. The second one did not. The third one required 2 different conversions. Okay. Okay. We'll move on to the next one. All right. So this is where we are now. Let me get the key out. This is what we're about to do. We're going to start with number 3. I already did some of them for you. Okay, so lesson number 2 talks about how you can use molarity as a conversion factor. So it's actually going to go ahead and give you the value for molarity, and it wants you to use that information to figure out, okay, if I want to make a solution that has this many moles, or if I want a solution that has this many liters, what proportions would I need in order to get Hold on. Okay, what proportions do I need in order to have that value for molarity? Okay, so since those 2 are already done for you, we're just going to skip over those, and I'll go ahead and start with number 3. Okay, so it says we have 5 moles of sodium carbonate, and we want to have a solution with a molarity, with a concentration of 5 molarity. What that means is for every 1 liter of solution, I want to have 5 moles. Okay, so this is how I started each of these problems. 5m, okay, there's a couple different ways. I'm going to show you how you can use this as a conversion factor, okay? And whichever one we choose is going to depend on what we're looking for. So there's 2 different ways you can convert this, okay? So you can write it as for every 1 liter, there are 5 moles, or you could write this as there are 5 moles for every 1 liter. That's the exact same information, okay? Like I said, which one we choose to use is going to depend on what we're looking for. And I'll show you what I mean by that in just a second. But both of these fractions mean the exact same thing, okay? For every 1 liter of solution, we have 5 moles of sodium carbonate, all right? So it says I have 5 moles, and I want the concentration to be 5 moles per 1 liter. Okay, so how many liters of solution am I going to need in order to have that concentration? I think the answer to this one is pretty clear, but I'm still going to show you how to work it out. Okay, if I want there to be 5 moles per liter and I have 5 moles, I'm only going to need 1 liter, but I'll show you how to work that out. Okay, so again, you always just start by writing whatever they gave you. Okay, so we have 5 moles, but this problem is saying how many liters do we need? Okay, we have moles, we're solving for liters. So I'm going to write another fraction. I want moles to cancel, and I'm looking for liters. So based on this, this is the conversion factor I'm going to use. Like I said, whichever one of these 2 that you pick every time is going to depend on what we're looking for. In this situation, we're looking for liters. The problem says how many liters, okay? Moles cancel, and the only way for moles to cancel is if moles is on the bottom. So that is why out of these 2 conversion options, I picked the one on the left. Okay, so then you just go and fill in the numbers. For every 1 liter, there are 5 moles. So 5 multiplied by 1 is 5. 5 divided by 5 is 1. So we're only going to need 1 liter. Okay, so this is actually the answer. But I'm going to show you what's good about these is it's really easy to check your answer. So the formula for molarity is moles per liter. All right, we have molarity. Okay, the problem told us that. We have moles, that's what the problem gave us, and we just solved for liter. So you can actually, when you're totally done, check your answer. 5 moles for every 1 liter would be 5 m. And that is exactly what the problem gave us right over here. Okay, so when you're done, you have a very easy way to check your answer. Okay, the problem gave you molarity. We knew it was 5 molarity. It gave us moles, and we solved for liters. So we actually have all 3. Now we can check our answer. Just make sure that, so I got 5m, and that's what the problem gave me. Okay, anybody have questions about that one? I know I muted most of you just to keep the background noise down.
Nope.
Anybody have a question about that? We're going to do a few more, so let me know. Okay. All right, for the last one on this page, how many liters of solution are needed? So again, we're looking for liters. If we want to create a solution with a concentration of 2.35 molarity, so for every 1 liter of solution, that means we want there to be 2.35 moles, okay? And we have 4.88 moles of solution. So I'm going to go ahead and still start by writing both of my conversion factors. So 2.35 m means that for every 1 liter, there are 2.35 moles. Or another way to write that is there are 2.35 moles for every 1 liter. When I say using molarity as a conversion factor, that just means using one of these fractions to convert to find the unknown that you're looking for, okay? So again, whatever they gave you, okay, I know that we have 4.88 moles. That is what the problem told me. And we want to know how many liters we need, okay? So I want moles to cancel. I'm going to put them on the bottom, looking for liters. So again, I'm going to use this because I want moles to cancel. I need moles to be on the bottom, okay? I'm not going to use that one this time, okay? And then you just go back and you fill in your numbers. 1 and then 2.35. Moles cancel. I'm left with liters, which that's what the problem asked me for, okay? So then to get your answer, you do 4.88 divided by 2.35. And you get something pretty close to 2. You get 2.08. So if I want my solution to have a concentration of 2.35 m, that's how many liters I would need. And I can check my answer. Molarity is moles per liter. Okay, so moles, the problem gave me that to begin with. Moles was 4.88. I just solved for liters, 2.08. Okay, whenever you divide, you get 2.35 m, and that is what the concentration is supposed to be. Okay, so when you're done, you can take your moles value and your liters value and just double check that you get the molarity value that the problem gave you. It's like a foolproof way to know if you did it correct or not. Okay. Anybody have questions about that one?
No, ma'am.
Okay, let's move on to number 5. Okay, so let me zoom in a little bit. Okay, number 5 says, how many moles are needed if I want to create a solution that has a molarity of so if I want to create a solution that has a molarity of 0.044, and it tells me how many liters I have, I want to know how many moles I would need, okay? So I'm going to start by writing my 2 fractions. So the molarity in this case is 0.044 capital E. What that means is for every 1 liter, I want there to be 0.044 moles. Or another way to write that is I want there to be 0.044 moles for every 1 liter. Those 2 fractions are the exact same information, okay? So, but this time we're looking for how many moles. So the fraction that we're going to pick this time is going to be a little different. So you just need to start with whatever the problem gave you, okay? So I have 1.74 liters. This time, I'm looking for moles, okay? So I want liters to go on the bottom, moles to go on top. So this time, I'm using this fraction because I want liters to cancel out and liters needs to be on the bottom. They're opposite from each other, so they're going to cancel. You just have to go back and fill in your numbers. That's why I like to start by writing those fractions first, okay? So then we're multiplying across this time, so we're not dividing. It's 1.74 multiplied by 0.044, and you get roughly 0.075 moles. That's the final answer, okay? But I can go back and check myself, okay? Moles divided by liters will give you M. I now have all three of these variables. So I just need to take my moles value, divide it by liters, and make sure that I get the molarity value that the problem gave me. Okay, so 0.075 moles divided by, because I had 1.74 liters, I should get 0.04. And you do. Okay. Questions about that one? Like I said, these two fractions at the top are the exact same information. Just whichever one you pick depends on what you're looking for. Okay, that's why I like to start by writing those first each time. Okay. All right, number 6 says a chemist wants to prepare a 3-liter solution with a molarity of 0.250. So what that means is she wants for every 1 liter of her solution for there to be 0.250 moles. That's what she wants. Another way to write that is she wants there to be 0.250 moles to 1 liter. The same information, just written 2 different ways. Okay, so she wants the solution to be 3 liters and for there to be 0.250 moles for every 1 liter. Okay, we want to know how many moles she would need. All right, so I'm going to start by writing what they gave me. So 3 liters, little fraction. Okay, I'm looking for moles. The problem says how many moles. Okay, I'm going to put moles on top of the fraction, liter on bottom, because I want liters to cancel. Okay, so if I want liters to cancel, I want liters to be on the bottom, I'm going to pick this conversion factor because moles is on top and because liters is on the bottom. Okay, then I just have to go back and fill in my numbers. So 3 multiplied by 0.250, you get 0.75 moles. That's how many moles I would need. That's the final answer. And again, you can check it. The problem gave me M. And now I also have moles and liters. Okay, so I can put those numbers in. 0.75 divided by 3 equals 0.25 M. And that's the value that the problem gave me right there. Sorry, I know I was moving around. Take a look. So once you're done, you will have the value for molarity, capital M. You will have moles. Oh dear. Oh, hold on. Okay. So sorry, you will have molarity, you'll have capital M, you will have moles, and you will have liters. So when you're done with these problems, you will be able to check yourself every single time. Okay? So just make sure that you get the molarity value that the problem gave you. Okay. Number 7 says if I have 0.822 moles of sodium bromide and I want to create a solution that has a molarity of 0.665, so that's my capital M value right there. Okay, how many liters of water am I going to need? Okay, so 0.665 molarity. All that means is for every 1 liter of water, I want there to be 0.665 moles. Another way to write that is I want there to be 0.665 moles for every 1 liter. Same exact information. So this problem gave me moles and it wants liters. So I'm going to write what the problem gave me. 0.822 moles. Okay, so I'm looking for liters, so I'm going to go ahead and put that on top of the fraction. I want moles to cancel, put that on the bottom. Okay, so if I want liters on top and moles on the bottom, I'm going to pick this one right here. And it's important that you have the 1 and the 0.665 in the right place, because if you accidentally pick the wrong one over here, technically the numbers are right, but they're not going to be in the right place, and you won't get the right answer. Okay, so that's why I like to go ahead and write them out both each time, just to make sure. So then I just go back and fill my numbers in. Moles cancel. I'm left with liters. You take 0.822, you divide it by 0.665, and you get 1.24 liters. That's how many liters I would need to have a concentration of 0.665 molarity. Okay, so I can check my answer. I now have all three of these values. I have molarity, I have moles, and I have the amount of liters. Okay, so the problem gave me moles. It was 0.822, and I solved for liters. It was 1.24. And that gives me 0.66 molarity. And that's what I should have gotten. Okay. Questions about that one? Okay, so we only have one more.
No, ma'am.
Okay, let's move on then. Okay, the last one, number 8. Same kind of problem. We have we have 2.5 moles of ammonia. And again, in any of these, it doesn't matter if it tells you hydrochloric acid, ammonia, carbon dioxide. It doesn't matter. This word could be anything. So don't let words like that stress you out, wondering what ammonia is or anything. It doesn't matter. Okay. If I have 2.5 moles of ammonia, I want to create a solution with a molarity of 1.087. So that is my capital E right there. How many liters of water am I going to need? Okay. So 1.087 means that for every 1 liter, I want there to be 1.087 moles. Or another way to write that means I want there to be 1.087 moles for every 1 liter. Same exact information. Okay. So the problem gave me moles. It says I have 2.5 moles. Okay. It says how many liters of water am I going to need? Okay. So I'm going to draw my fraction. I want moles to cancel. I'm looking for liters. Okay. So if I want moles on the bottom and liters on top, I'm going to pick this fraction right here. Okay. So I'm going to fill my numbers in. Moles cancel. I'm left with liters. So I'm going to take 2.5. I'm going to divide it by 1.087, and you get something around 2.3 liters. That's how many liters I would need in order to get a concentration of 1.087. Okay, so I'm going to check my answer. Molarity is moles per liter. And I have all three of these numbers here now. Okay, so I should be able to check. And whenever I divide, I should get this number. That's my capital M right there. Okay, so moles, the problem gave me 2.50. I solve for liters, 2.3. And when you divide, you get exactly 1.087. And that is exactly my number for molarity right there. Okay. Questions about any of those? Does anybody need to see any of them again?